Well, good day. It's another fine day in trigonometric land. So today we are going to work on evaluating trig functions. All right. Now, we've done some of this already, but this whole lesson is on that. So it's kind of a rehash of everything we've done before, kind of putting it all together. And then that will allow us to find essentially exact values for all special angles. Okay? And at the end of this, you should be able to have the circular trig function chart filled completely out for all the special angles. You should be able to do that on your own if you aren't already. We'll also talk about how to use the regular table for trig function angles and trig functions. We'll talk about that again. And we'll use these as well as what your lessons do, which is the way I used to do it. They just do them all from scratch. And so we're going to do all of those today. And we'll start from scratch and then we'll make these tables and charts, which will kind of shorten our effort. And you'll start to use one or the other of these probably more often depending upon which one you like the best. Alrighty, let's get going. And so, just so you know, guys, I just did this whole page and I'm redoing it because I forgot to press record. Oh, well, Mr. Ridpass funny. You can enjoy that. So let's get back and let's figure this one out again. So what you need to do is you need to fill in this unit circle. I am going to have this page in your lesson so you can do it. And I'll probably put something like fill this in by it. And this is something you should then hole punch and keep in your notebook and use it all the time. It'll be something you use every day. All right? Now, the first thing you want to do is you want to go through and say what each of these lines represents. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. And then you want to also say what they mean in terms of radians. 0 radians, pi over 6 radians, pi over 4 radians, and pi over 3 radians, pi over 2 radians. Okay? And then you want to be able to figure out what the ordered pairs are. Now, we did this before in an earlier lesson, but we're going to do it again. If you'll remember, we marked this as a unit circle. It doesn't have to be a unit circle to figure this out, but a unit circle makes it a little bit easier. All right. And since it's a unit circle, the hypotenuse is 1. And we now know the angle is pi over 6 or 30 degrees. All right, that's our angle. Since this is now a 30, 60, 90 triangle, we now know that the shorter leg is half as long as the hypotenuse, and the longer leg is the square root of 3 times the shorter leg. That's our 30, 60, 90 triangle theorem. Since we now know that information, we know that looking at this, that this is our x value, how far out we went, and then how far up we went is our y value. So the x and the y that correspond to a 30-degree angle or pi over 6 are square root of 3 over 2 or 1. And from this, we could then say sine of pi over 6 or 30 is equal to the y, which is equal to 1/2. cosine of pi over 6 is equal to the x, which is square root of 3 over 2. And then, of course, if you wanted to do tangent of pi over 6, that would equal the y over the x. So you'd get 1 over 2 over square root of 3 over 2. Since they're over the same denominator, those divide out, and you'd be left with 1 over square root of 3. And this is how you would find every trig function on this page. Now, you don't have to draw all the triangles here and get them all mashed up. You can draw them on a separate piece of paper and let them help you figure it out. But remember, you're doing 30s, 60, 90s, and 45, 45, 90s all the way around this. Now, just to help you out a little bit, I want to show you this one here. Suppose we make a 150 degree angle, okay? So this one's going to be 150, which is 5 pi over 6, okay? And that's what that angle is, all right? But here's the key thing we learned in the last lesson. We would then find the reference angle, which is the angle it makes with the x-axis, and this reference angle would be 30 degrees or pi over 6, all right? Therefore, we would know right off the bat that the x's and y's are some particular values that match up with pi over 6 in the first quadrant. In fact, the length, if this is 1, this is going to be 1/2, and this is going to be square root of 3 over 2. However, the big difference is this. Notice this square root of 3 over 2 is going on the negative side of the x-axis, while the 1/2 is still on the positive side of the y-axis. So this square root of 3 over 2 needs to be negative. And then our x is negative square root of 3 over 2, and our y is 1/2. And now I have that filled in correctly. So I can come in here and I can go, oh, what's the sine of 5 pi over 6? Well, it's still equal to y, or 1/2. What's the cosine of 5 pi over 6? That is equal to x, but in this case, the x is negative square root of 3 over 2. Okay? And then when you go to find tangent or any of the reciprocals, now you have to pay attention that sine is positive and cosine is negative, or in other words, the y is positive and the x is negative. So in this case, since tangent is y over x, tangent is going to be negative 1 over the square root of 3. Okay? Because it's a positive over a negative. All right? And this should show you that the sign on a variable expression is not actually its sign. Because this looks like a positive y over x, but in reality, the x was a negative number, so that y over x is actually less than 0. All right? Your job is to fill out the rest of this table. Okay? Now, what we can do from this point is we can summarize this circular table in a horizontal table, okay? And we've done this before, but we have 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, which are 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, pi over 2. And I always say sine, cosine, and tangent. I always say them in that order, okay? Now, as I showed you before, all you have to do, every one of these is divided by 2. The numbers go in order, 0, 1, 2, 3, 4. And then we take the square root of all the numerators, okay? Once you do that, then you can simplify. The square root of 0 over 2 is just 0. So we'll erase this, and we'll put 0 in there. The square root of 1 over 2 is just 1 over 2. That's 1/2. Square root of 2 over 2 is simplified. Square root of 3 over 2 is simplified. But square root of 4 is 2, so this is 2 over 2, or just 1. So now I have created this table. Since sine and cosine are cofunctions, the cosine of the complement is equal to the sine of the angle. For instance, if the sine of an angle 30, so if I look at this table, the sine of 30 degrees is 1/2, then I find the complement of that angle, which is 60, and whatever is there is what the cosine of 30 will be, okay? Because the cosine of 30 is equal to the sine of 60. Complementary angles, sine and cosine of complementary angles are equal. That's what cofunctions are, all right? And in fact, because of that, all I have to do is write these numbers in reverse. Oops, 0. All right? And now I have cosine. And then just for kicks, if I take them all as a fraction, then that's tangent. Because tangent is y over x, but sine is y and cosine is x, so y over x is tangent. So I just make fractions. And so I get the answers. 0, 1 over the square root of 3, 1, square root of 3 over 1, which is square root of 3, and 1 over 0, which is undefined. All right? Now, since I have made this part of the table, how do I use this table? Okay? What if somebody comes up to me and they say, gosh, what is the secant of 45 degrees? Well, then I go, secant is the reciprocal of cosine. All right? So it's the reciprocal of cosine of 45 degrees. Okay? This is how I think about it right here. Well, what's that equal to? Well, the cosine of 45 is square root of 2 over 2 right here. Okay? Square root of 2 over 2. The reciprocal of that is 2 over the square root of 2, which is equal to just the square root of 2. Now, if I wanted, I could put a secant line down here. Okay? And I would put square root of 2 right here, because it's the reciprocal of cosine. All right? And you can play that game all the way through this. Okay? To find angles. Now, we can make it just a little bit harder. We can do one more thing, make it a little tougher. What if somebody asked me what the sine of 4 pi over 3 is? Okay? I don't have my circle, all I have is this table. Well, if you'll remember, all students take calculus. This matches up with quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And in quadrant 1, all trig functions are positive. In quadrant 2, students, only the sine function is positive and its reciprocal cosecant. Okay? In quadrant 3, only the tangent function goes with tangent is positive and its reciprocal cotangent. And then in quadrant 4, only cosine is positive and its reciprocal secant. Okay? Now, why is this so? Because xy values are both positive in the first quadrant. The x's are negative in the second quadrant. Both x and y are negative in the third quadrant. And in the fourth quadrant, the y is negative, but not the x. And that's what this is for, okay? It's applying that to these trig values. So when I say the sine of 4 pi over 3, how do I want to do this problem? The first thing I want to do is draw a correct picture. 4 pi over 3. Here's pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So 1, 2, 3, 4 pi over 3 is a third quadrant angle. Third quadrant. All right. Since its reference angle is pi over 3, okay, the value I'm looking for would be square root of 3 over 2. However, sine is negative in the third quadrant. That's this thing right here, because y values are negative in the third quadrant. So the sine of 4 pi over 3 is equal to negative square root of 3 over 2. You can do this by using your circle table you made and just looking up 4 pi over 3. Or you can use this table, which is very easy to make. Like I can make this in 30 seconds if I have to, and I'm taking a trig test, right? If I forgot my notes or can't find my notes, I know how to, I just divide by 2's, take square root of 0, 1, 2, 3, 4, rewrite those, and then write them backwards, and then take fractions. And once I have that, I can use that to find any exact angle. So here's a classic example where we are trying to find the secant and the cotangent, and we're trying to work all those things out, okay? Now remember, secant's associated with cosine. So pi over 3 is here, right? 2 pi over 3 is here. So that means if I'm doing negative 2 pi over 3, I'm going to do it the opposite direction. So negative pi over 3, negative 2 pi over 3. So here's negative 2 pi over 3. So what's the reference angle? Pi over 3 is the reference angle, right? And so I want to find that value. Now, there are 3 ways I can find that value. So let's go through all 3. One of them is I could look at the right triangle. And I could remember that if this is 1, pi over 3 is 60, all right? So the shorter leg is half of that, and the longer leg is the square root of 3 times the shorter leg, okay? Now, if you notice, this goes in the negative direction, and this does too. So the so the xy is, the x value is negative 1/2, and the y value is negative square root of 3 over 2. Okay? So that's our xy. All right? So cosine of theta is equal to x. Therefore, secant of theta is equal to 1 over x. Okay? My x value is negative 1/2. So the reciprocal of that is going to be negative 2. So the numerator is negative 2. That's one way to do it. Okay? Another way to do it is I could go to the circle diagram that I have made. Okay? So you have made this, you've gone through, you've made sure it's all correct, and you know that negative 2 pi over 3 is here, and that's exactly the same as 4 pi over 3. All right? And so the reference angle is 30, and you would have this written down for your xy values. Okay? And so you want the secant of that, which is 1 over x. And so you know that from the function definitions when we did them with the circle function. Okay? And so you would also choose the reciprocal of negative 1/2, which is negative 2. Okay? Now, we want to do the cotangent of 19 pi. Oh, what's the other way to do it? Oh, I'm sorry. The third way to do this, we should talk about the third way to do this, is just use the table, right? So cosine's here, pi over 6 is here. It's 1/2 for sine, and it's square root of 3 over 2. That's pi over 6. Sorry, I need to do the pi over 3. I apologize. For sine, it's square root of 3 over 2. And for cosine, it's 1/2. So these are first quadrant values. So in the first quadrant, cosine is 1/2. But we know we have a third quadrant angle. So the cosine is negative in the third quadrant, because only tangent is positive. So that means cosine is equal to negative 1/2 there. All right. But secant is the reciprocal of that, so I get negative 2. So there are 3 ways to think of this. Now, in general, since you're a beginner, do not do the second 2 very much. Okay? Always draw the right triangle and think it through. Really connect the 30, 60, 90, and then use these to kind of supplement. It's just a little thing I think is really important that you should get really, really good at. So then you come to 19 pi over 6. Okay? So 19 pi over 6, I want to know what quadrant it's in, right? So I know 2 pi is equal to 12 pi over 6. So if I go around the circle one time, that's 12 pi over 6. So I only have 7 pi over 6 left, all right? And so that means I'm going to go to right here. So this is also a quadrant 3 angle. The reference angle is pi over 6. That's the reference angle. So I'm a little faster. Here's pi over 6. I have sine, cosine, and tangent in my table. So you don't have to make this table. I'm just remaking it. And if you'll remember, sine was 1/2, cosine was square root of 3 over 2, and tangent was 1 over the square root of 3. Okay? So when I look at this, cotangent of this is the reciprocal of tangent there. Okay? And so I need to take the reciprocal of this. So the cotangent of 19 pi over 6 is equal to square root of 3 over 1, or just the square root of 3. However, that's cotangent. It's in the third quadrant. But in the third quadrant, because of all students take calculus, we know tangent is positive. Therefore, its reciprocal cotangent is positive. So the answer for the cotangent of 19 pi over 6 is square root of 3. And so there's our answer. It's negative 2 over the square root of 3. Now, because they like you to simplify, you're going to have to rationalize the denominator. So we end up with negative 2 square root of 3 over 3. And that would be the answer for that particular problem. Now, I divided here, but I could add these together, subtract them, multiply them. And so you can get all sorts of answers. Okay? That is what your lesson requires you to do. Good luck. Practice these, do as many as possible. Okay? Bye.